Hey, Miguel.
Hi, Carrie. How are you?
Good. How are you?
Doing well, doing well.
Have you been looking at the Discord projects? They're exploding.
Yeah, actually, I was very happy yesterday night. I was, looking around and yes, amazing actually. A lot of discussion. I'm very happy.
Yeah.
Yeah. So
I really want this food ingredients cooking styles thing to happen. That is super interesting. And there is a postdoc at SFI who is not working on that, but is interested in like spices and sort of the evolution of cooking styles. And so I don't know that she has expertise to offer, but if you
nice.
do
Yeah.
pursue it, I think there would be a lot of interest.
Yeah. Do you remember what is her background?
So the SFI postdoc Anjali actually comes from a business school background. Her undergrad degree is in chemistry, I believe, but then she switched and was at, I think, Stanford School of Business, but looking at interactions in organizations. So sort of how, I'm going to use probably the wrong words, but like how the culture of a company changes. And specifically, like she was looking at mergers and acquisitions and like sort of who was the dominant partner in those and whether their culture then dominated the
Wow,
merger and then
nice.
how that impacted success. So I don't know how that intersects with this interested in
Spicy.
like spice trade and how that influenced different foods, but somehow it's in there.
Yeah.
Complexity, right?
I don't know if Aaron is already here with us.
Aaron is here. Yes, and he's waving to you, so he's
Okay.
ready.
Yeah. I can, there are too many people, so I don't know where is Aaron, but hello, Aaron. So today talk, actually, we will begin shortly with that. And this is more or less the agenda for today. And then after, of course, we will have, we will meet there in Complexityville in Gather, in this application, gather.com or something like that. I don't remember the name exactly. But first of I would like to say that I'm very happy for all that is happening in terms of the project. Very nice, actually, as Karen mentioned. And again, the dynamics for today will be more or less the same as yesterday with David Krakauer. Um, Please use the chat to post question and raise the hand too. Actually, yesterday that worked, I think, very, very nicely. And today we will have Aaron Clauset. We share actually some time there in SFI, so I'm very happy to to have Aaron with us in this program. Aaron is an associate professor in the Department of Computer Science and the Biofrontier Institute at the University of Colorado in Boulder, and an external faculty of Santa Fe Institute. And he was also an Omidyar fellow. We shared some time together at that time, I remember. Very nice days, many years ago. His work generally focused on the understanding of mechanism and patterns that emerge of collective action, and he focused on network theory. He produced very nice results. I will say that foundational research in some of the areas of network. So I think it will be very nice for you to have all the knowledge of Aaron today. So welcome, Aaron. It's a great pleasure to have you here, actually. So I hope you enjoy the time with us here today.
Thank you, Miguel. It's wonderful to be back and lovely to see you again. Miguel and I were postdocs 15 years ago together at SFI. And I am here at SFI right now in an office, live streaming to you. So let me get my window up. Okay. Okay, so I'll give a seminar on networks, prestige, and the spread of scientific ideas. The purpose of this presentation is to give you a sort of a deep dive into a particular topic and use that as a way of learning about networks and how networks can help us understand complex systems. So I want to start with a very general statement, a question. What are networks? And maybe you've seen some of this before or heard some of this. This is my perspective on a very broad and interdisciplinary topic. Essentially, networks are an approach. They are a representation of structural complexity for a complex system, and they provide a way of connecting the microscopic structure of a system, whatever that is, the components, the parts of it, with the macroscopic patterns that you might see. And so in that sense, they give you a layer between sort of like the low level, the individual components, and the systems level, the population level above. And the structure of the network is what allows you to see how information and dynamics go from one level up one. And so they're really a structure above the individual components, but below the level of a system or a population. The learning goals for this seminar and even the Q&A afterwards are primarily to build intuition for you, to help you understand how to reason about networks, to expose some key concepts, even to highlight some big questions about networks and also the application we'll talk about. I'm going to use science itself as a model complex system. And I think that's a really rich direction to move in part because like we are all participating in that larger community, and trying to understand how it itself is a complex system can both allow you to use your own experiences to understand what it means for complexity to apply to a social system, and also to understand complex systems more generally, because there are analogs, of course, between some of the dynamics in science and other complex systems. And of course, we'll apply network ideas in order to do this. But I want to point out that this is not a substitute for technical coursework. If you want technical coursework, you might take a look at, say, Mark Newman's wonderful textbook on networks. I use this textbook in my graduate level course on network science. And I also have two courses I teach at the University of Colorado Boulder, both on networks, one at the graduate level, which is Dan Larimore, another former postdoc at SFI, and I both teach network analysis and modeling, for which I've written about 150 pages of lecture notes, which are freely available online. You can find them at that GitHub link. And there's an undergraduate course called Biological Networks, which the first half of it is basically network science, and the second half of it is like, let's use network science to understand biology. And there's another 150 pages of lecture notes that I've written for that, both of which are sort of textbook style. So you can learn some technical material that way, or you take a course at your home university, or there are some other online courses as well. Okay, there's also lots of tools available for networks. There's various software packages. NetworkX is the one that we use in my classes. There are standalone network editors, some of which you've probably encountered already. And then there are many network data sets available today. My group at Colorado runs this thing called the Index of Complex Networks, which is like a listing of various research quality network data sets that are located at various other places. Sometimes they've been archived with individual papers, sometimes they are other repositories, et cetera. The icon does not store network data, or rather it points you to where it's stored so you can go learn about those details. This screenshot is a bit outdated, but roughly speaking, there are about 5,000 networks that icon lists from all different types: social, biological, informational, economic, transportation, et cetera, et cetera. And so if you're looking for ideas for projects or data sets that you want to use in your exploration of networks or other kinds of questions, icon is a wonderful way to find inspiration. You surf the listing and see what people have looked at, and inevitably you'll find a system for which there is a network data set that you had no idea even existed. And that can be really fun. Okay, so now moving on to thinking about science as a complex system and how we can use networks to understand it. And I want to start with a mildly provocative statement, which is an adaptation of a statement about biology. And the statement is, little in academia makes sense except in the light of prestige. And I'm going to try to argue that that is true and use networks to do so. And then maybe we can have a discussion afterwards about other examples or counterexamples. Okay, so what I want to start off by saying is that prestige really pervades and structures the scientific ecosystem. And by ecosystem, I really mean like all the different players in the scientific enterprise, not only individual scientists, but also departments or institutions, funders that make grants, say the National Science Foundation or private foundations, even editors at journals, for instance. Journals themselves are players in the scientific ecosystem. And all of these entities have different goals sometimes and different approaches. And my argument is that prestige structures the way that they interact to a large extent. Prestige shapes who gets jobs and where they get jobs, who publishes in which journals, who works on what ideas, which I think is a fascinating question. And of course, who shapes, who gets what resources, grants, students, attention, et cetera, et cetera. And so I want to leave you with a question to think about throughout the rest of this presentation, which I don't know the answer to. And I don't know even how to answer this question, but I think it's an important question to consider, to ponder, which is how many good scientific ideas are left unexplored because they lack the right markers of prestige. So if prestige is the currency that drives the scientific ecosystem and the attention in it, then if someone or an idea don't have the right markers, don't have the right currency, then that idea may not get explored. And yet it may be a really good idea. So to what degree, essentially, is our system a true meritocracy in the sense that ideas rise and fall based on their merits alone versus a system in which prestige is really, reputation is what's driving these things, okay? All right, so what is prestige? Well, prestige is kind of like rankings, but everybody hates rankings, especially the US News and this National Research Council thing that the US occasionally does. Many countries have their own internal ranking systems and they all stink. And the reason everyone hates them is not only because it like reveals the game, but also because academics who have studied these things routinely criticize them as mostly measuring the inputs to science, like how much fame and fortune does a university have to begin with. And they don't really measure outputs or value added. Like, suppose you go to Harvard, like, great, you are already extremely privileged to get into Harvard, typically. How much does Harvard actually add to your potential future output? That's a hard question to answer. And yet it gets right to the point of what value does Harvard play in the scientific ecosystem. So what we need is sort of a data-driven approach of extracting a prestige ranking that looks at outputs in some way. And this is very tricky. One very popular way is to look at the network of who hires whose graduates as faculty, because if we believe that the departments making the hiring decisions are being very careful about it and trying to select the best candidates and so on, then in some sense, this is an economic market and the producers are departments and they're also consumers. And if a producer produces a good that is very popular, then many other consumers will want to buy that product. In other words, hire those graduates as faculty. And so this defines a network in which the PhD granting universities are the nodes. They are both producers and consumers. And an edge represents the movement of a person, a graduate, from University U, where they got their PhD, to University V, where they become faculty. Okay, so this is one particular view of prestige. You could look at other kinds of value-added notions, but this is maybe a relatively easy one to measure. So in this sense, prestige then becomes a measure of placement power, the ability to place your graduates as faculty at other universities. But to measure this notion of prestige, we really need faculty hiring data. So we're going to collect all that data. This is a project that we did, started almost 10 years ago, in fact, although it took several years to get all the data. The data looks like this. So this is a record in the data set for one of my colleagues, Jim Martin, at University of Colorado. The data set total covers 19,000 tenure track faculty at 461 departments in 3 different fields: computer science, business, and history. We chose those fields because they represent sort of very intellectually distinct traditions. And it took about 4,000 hours of manual data collection in order to get this data. And so the transition that we're most interested in is this one, the one where you have your PhD. In this case, Jim got his PhD at Berkeley in 1988, and then he transitioned as an assistant professor to University of Colorado Boulder starting in 1989. Okay, so this is the edge from U to V. We're going to get this for essentially all faculty in these fields, and that's going to create a network. Here's a small snapshot of the sort of 10 most famous departments in computer science. And I've highlighted the flows from MIT, which is a very large producer of computer science faculty. And you can see, for instance, that there's a large flow from MIT to Carnegie Mellon, and a smaller flow from MIT to Caltech, and so on and so forth. And so this network already is showing you interesting information about the relative roles that different universities play in the production of faculty. We'll come back later in the presentation to talk about what that means for the spread of ideas. But basically, faculty hiring is a network, as we've described. Okay, so now here's everything. Here's the whole network for computer science, which is my field, all 205 PhD granting departments in the US and Canada. You can see a couple of familiar names, maybe with the big ones. Those are the large producers and so on. But I've colored the edges. Actually, Dan Larimore made this figure. Dan colored the edges blue if it was an edge that pointed down in this hierarchy. So this would be clockwise around the circle. And pink if that arrow goes up. And so there's sort of two qualitative things you can pull out of this simple visualization. One is that everything's blue, right? Like you can see some pink in there. There are some people who moved up in the hierarchy, but like the vast majority moves down. Okay, that may not be a qualitatively sort of earth-shattering conclusion, but the quantification of it, to be able to look at exactly how much it is, that's useful. To know that it's something like 90% of edges pointing down. All right, it's not 55%, it's not 70%, it's 90%, almost all of them. The other thing we can see is that there's more density on the right side than the left side, right? And that really indicates the fact that many of these edges, right, are coming from the more prestigious universities. So the most prestigious, Stanford, computer science, and sort of goes down the prestige hierarchy as we go around. And so the fact that these are edges coming from, going to, really shows that not only are the big departments the more prestigious ones, but also they produce more faculty. Okay, so those are the sort of the two qualitative things we can get out of this, but we can dig in much, much deeper into this network. Let's look at just faculty production. This is like looking at the out degree and in degree. So who produces faculty in the system? We can quantify this using a Lorentz curve, which actually comes from economics. From this, you can compute the Gini coefficient. Essentially what we're doing is we're plotting the fraction of faculty produced as a function of the fraction of institutions after we've sorted based on, and decreasing order of production. And what you can see is that it's enormously unequal, right? As you would know, if you talk to anyone in academia, people typically have degrees from a handful of universities if they are sticking around in academia. And in computer science, 18 departments, about 9%, produce half of all tenure track faculty in the US and Canada. 18 departments, and you could name them all. You might miss a few on the first pass, but you get them all on the second pass. And in fact, 76% of departments are net consumers, meaning that they hire more faculty than they produce. And so the lower set, in fact, the lower 50% of universities produce almost no faculty that get placed at other universities. So it's really dominated by a small number of institutions. And we will explore one of the consequences of that in the second half of this presentation. But even among those elite universities, the inequality in production is stark, right? So the top 10 universities in computer science produce 1.6 times more faculty than the next 10 do. And so it's not really an equal game even among the rich in this case. This is very much like economic inequality, in which the 0.1% richest people are far, far richer than the 1% richest people, and so on. Okay, and we see this for business and history as well. Okay, so it suggests that this may be a common phenomena across all different fields. Okay, so now we want to get back to this question of trying to quantify prestige through these faculty hiring networks. And what we want to get is a picture like this, right, where we take this network and we want to embed it in a one-dimensional space, such that there's an ordering, a linear hierarchy of the nodes under some criteria. And essentially, any ranking of the universities is a permutation of the order of those universities. And there are a lot of those, in factorial, different permutations. And we need a score function in order to evaluate which one is a better hierarchy than another. And you can write down any number of interesting score functions that you like. In this case, we're going to use something called minimum violation rankings, which has a long history both in social theory and in animal behavior, actually, for extracting dominance hierarchies or prestige hierarchies. There's a wonderful review article in the footnotes that sort of summarizes some of the work that was done in this in animal behavior. But the basic idea is that I want to find a permutation such that I minimize the number of edges that point up that ordering. Okay, so the picture here, you can see visually that there's much more weight that points down in this hierarchy than there is that points up. And this is in fact the minimum violation ranking for these 10 nodes. So that really is equivalent to a task called minimum feedback arc set problem in computer science, which is known to be NP hard. So in general, we don't expect to find the global optimum for this system, but we do want to find something that's pretty good. And so what we're going to do is find this ordering. You can write down a mathematical equation that sort of represents this score function. But because in fact, for our system, there are many such permutations that have the minimum and they disagree on slight things. So for instance, consider a tree, right? So at the end of the tree, I have 2 nodes. They both hire 1 faculty. The relative ordering of them in the permutation is the same, right? If I switch the order, I have the same number of violations than if I switch the order back, okay? So those 2 orderings are the same. And so somehow we want to sample the set of these things and extract a consensus hierarchy. So to do this, we'll use a very simple technique, just a zero temperature MCMC. It's a hill climbing function that allows us to sample the set of things that all have the same minimum violations. We're just going to run this thing for a long time and assume that what we get out of it is pretty good. Okay. So to give you some intuition about how this works, this minimum violation ranking idea, here's that the adjacency matrix for those 10 nodes in that little network of computer science. So Stanford, University of Washington, Yale, Princeton, Harvard, et cetera, et cetera. And the number in each of these cells is the number of hires that go from that node I to that node J. So you can see that Stanford has 9 people that got trained at Stanford on its faculty at Stanford. So that would be a self loop or a set of self hires. And CMU, which is the other sort of large number there, is 23 people are self hires. And then down at MIT, 27 people are self hires. So that diagonal represents the people who got their degree at institution I and also our faculty at institution I. So if we just choose a random ordering, then and just count up the number of violations, the violations actually, let's see, get my draw figure, is just the sum essentially of this lower triangle. Yeah, there we go. So I want to find the permutation that minimizes the weight of that lower triangle, because those are all the edges that point from a lower rank thing to a higher rank thing. Okay, so the random thing produces 151 violations out of 267 edges. You know, you can sample randomly. It's roughly the same for most of these random permutations. We can do much better. So for instance, if we order by production, by out degree, then we get 99 violations, so much better. And you can see that that has clustered much of the production among the top few ranked nodes. So MIT, Stanford, Berkeley now, that white block represents the largest production of faculty in this little tiny subsystem. And you've also sort of reduced the number of people who are moving up in the hierarchy and the lower right. But you can do even better than sorting by out degree by using the minimum violation ranking sampler. If you do that, you can crunch it down to 82 violations, and that is the minimum for this particular network. And so that gives you a ranking. So we can use this minimum violation ranking approach in order to do this sort of one-dimensional embedding that gives us this interpretable prestige hierarchy where we know what it means for a node to be at a particular location, right? Because that tells us its placement power, how many faculty it can place lower in the hierarchy while minimizing the number that move up in the hierarchy. Okay, so what do these prestige hierarchies look like? We can use this tool now to explore the structure of the network to understand something about the shape of academia and how is it that prestige drives this the structure. What do they tell us about the structure of the faculty market? Here's an example of the ranking you get out of computer science. Here I'm only showing you the top 60 universities by the ranking, but you can see some very familiar things. So for instance, you've got Stanford and Berkeley, MIT, Harvard, Caltech, and Harvard at the top, for instance. And then as the prestige numbers go down, you see places that you might not have heard of, although maybe a little bit, okay? One nice thing about these prestige rankings is that because we're sampling the set of MVR orderings, we can look at the uncertainty. So we can quantify like how certain are we that, say for instance, Toronto is at its particular location. And you see that for Toronto, there's much more uncertainty. Sometimes it bounces around a lot more just based on whether or not its faculty end up going many places, or fewer that go places. So this is nice. This gives us this one-dimensional ordering along with the notion of uncertainty. How do we know that this is a reasonable ordering? Well, you can correlate it with other authoritative rankings that people seem to think are reasonable. So if you take the correlation coefficient with like the US News ranking for computer science, or the National Research Council, or just the eigenvector centrality score, what you find is that our prestige rankings correlate with the US News and NRC scores about as well as the US News and NRC scores correlate with each other. So this really suggests that we're capturing something underlying about this prestige system to basically the same extent that these other authoritative measures can do so. Okay, so this prestige pie captures this placement power notion. We have this uncertainty measure along with it. We find sort of similar qualitative results, but different orderings, of course, for business and history. So this is nice. This gives us some sense that we're on the right track with this one-dimensional embedding. We can then look at how people move inside this embedding. And in computer science, what we find is that 80% of people move down, 8% of people stay put, 8% of faculty receive their PhDs from the same place they are faculty. Now, they may have moved away for a postdoc and come back, for instance, or even moved away for a faculty job and eventually come back later. But in the end, for our snapshot, 8% of people are self-hires, but only 12% actually move up. So a small fraction of all faculty receive their PhDs at a less prestigious university than they currently teach. And the average distance is 47 steps down in this hierarchy, which is about 25%, right? So that's a huge step down. And when you plot the distribution of these delta pies, these, if I got my PhD at University U and I'm faculty at V, what's the delta pi between those two places? What you find is that, like, if you get your PhD at an elite place, then you're much more likely to have a faculty job at a nearby prestige location. And if you don't do that, then you tend to slide pretty far down the tail. But if you get your PhD from a lower prestige place, like there's still some room to move down. But if in order to stay at a nearby prestige place, you're now competing with this sort of deluge of graduates coming from further up in the prestige hierarchy. So this already is beginning to tell something about dynamics in the system, the way competition is structuring the placement of faculty and driving this kind of thing. So we essentially find that the elite universities, those 10, for instance, that I showed you in that small network, they're really driving a huge fraction of the overall dynamics in this faculty hiring market. And if you go to a random department in the US and just like look at where people got their degrees, you find the elite places. Even people who are at the most unknown university in your field, chances are most of them got their PhDs at places you have heard of. Okay, so let's use this network to try to get a sense of this, core, the elites and the others. Okay, so let's use this notion of distance. So how far in the network is some node U from some node V? Okay. So this is an average geodesic path length. So we can look at the number of steps in this hiring network. And because this is a directed network, the path length between U and V is maybe different than the path length from V and U. And that's going to be critical here. And we're just going to ask, how does this notion of like how big the world feels or looks to a particular node vary with prestige? So a node that's in the core of the network might have a smaller distance to the rest of the network than a node that's located at the periphery. It might have a longer path length to get back to anyone else. And so what we find essentially is that this average path length as a function of prestige increases, right? So the less prestigious a university is, the more peripheral it is inside this academic hiring system, inside this prestige system. And if you visualize these little networks from the perspective of the particular node that you're looking at, you can see how compactness changes. So for instance, Stanford, which is the #1 department in computer science under our ranking, is at most 1.5 steps from everybody else, because they have so many graduates placed at so many other places that for them the world seems very small. Whereas if you go down to a place like BYU, which is much more peripheral, they have many fewer graduates that have been placed as faculty elsewhere. Then from their perspective, there are many, many more steps in the paths to get from BYU to any other place. So if you imagine this network of faculty hiring as being a set of information conduits, information that starts at Stanford will percolate much more quickly than information that starts at a place like BYU. So this notion of core periphery is critical for the spread of ideas, perhaps. And we're going to actually investigate that idea in the second half of this talk in a moment. And so really, you can, if you're willing to be a bit provocative, you can talk about like homelands and colonies, right? Because the homeland is where most faculty are produced, and the colonies is where they move to. And so this kind of raises the idea that prestige is actually influence in a very real way, because this homeland, the main producers of faculty in this system, they have influence over everybody else's research agendas and research communities and even departmental norms and the disciplines. I mean, I was sitting on a committee in my department many years ago, and one of the other faculty who received their PhD from Princeton, you know, just pick a random top 10 place, for instance, said, well, when I was a doctoral student at Princeton, this is how we did it, and I thought it worked pretty well, so why don't we just do it here? And it's a beautiful example of faculty hiring being an influence mechanism in which just like community practices move across these faculty hiring edges, because faculty are kind of like information conduits, or they're packages of experiences, and we replicate the things that we think worked well, but what we think worked well are things that we experienced ourselves. And that come from our doctoral training where we did that, and which is typically in the homeland. Okay, so to wrap up this section, prestige really pervades and structures the academic ecosystem, in particular through the faculty hiring network. So placement power really quantifies reputation via outcomes, not inputs. So it's a nice measure of prestige in that sense, better than US News perhaps. And it really reveals this core periphery structure of academia in which faculty flow from the core to the periphery. A modest fraction manage to stay inside the core as well, the homeland. And a very, very, very small fraction of faculty flow upstream, flow from the colonies, for instance, back into the core. And so prestige becomes influence via this placement. And so I want to return to this question of how many discoveries are left unmade now, modifying it slightly, because hiring hierarchies so strongly determine who gets faculty positions. Okay, so now let's take that question and let's dig into it in much more detail. Right? So we all know that some ideas spread further than others. Like some papers are cited just a tremendous amount. In fact, Nature did this piece in 2014 about the top cited papers, you know, in all of science. And the figure's a bit small, you can look it up online. But the top papers received just a mind-boggling amount of attention. And so these ideas clearly have spread really far. And you've probably heard the statistic that 80% of academic papers are not cited even once. Now, that statistic is disputed to some degree, kind of tricky to calculate it because you need access to all the data and so on, and we don't actually have a good source of all the data, not entirely. So there's some nuance to it, but the point still is that some ideas spread further than others. Okay, so why? Well, there are three really, in my mind, mechanisms, explanations for this. Two of them are easy to come up with. One is that, oh, well, there's genuine differences in merit, right? The sorting that we have in terms of which ideas get more or less attention is unbiased, right? Like this is the pure meritocracy perspective, that if an idea is cited very well or receives a great attention, it's because it's just a good idea. Of course, we also know for a fact that there's plenty of biases in the system as well. And there are non-meritocratic social processes. So for instance, fame, prestige, seniority, discrimination, for instance, there's this thing called the Matilda effect, which is a well-documented phenomenon in which men and women who both work on the same idea don't get equal credit for that same idea, right? So typically the men get more credit and the women get less credit. This is a historical, easy to document historical phenomenon. And so this is an example of bias in the system in terms of the spread of ideas, is that ideas from some people are discriminated against, and so therefore they get less attention. All right, so we have genuine merit, unbiased, meritocracy works, hooray. And then we have, racism, sexism, et cetera, discrimination on some characteristics, right? So biases in who gets credit and opportunities. But I'm going to propose that there's a third explanation, which is non-meritocratic structural factors. So the second one you can imagine as being non-meritocratic individual factors, things about individual people. But I'm going to argue that the system itself, independent of the individuals, the system itself drives attention in unequal ways, right? It's a mechanism that explains biases and who does which work and where. In some sense, it's like agenda setting theory, right? Who sets the agenda that other people follow? The idea is that, as I said earlier, scientists we carry ideas from one place to another, and we talk about the ones we like. And so if we carry ideas from our PhD institution to our faculty institution, or really any institution, if you're a postdoc or whatever, any institution, you are carrying ideas with you. You are a package of information. And where you got your information will impart structure where that information goes. And if some places produce more packets of information that get spread through the system, then the information that's born at those places will spread further. Okay. So in this sense, differences in placement power, faculty hiring, will drive epistemic knowledge inequality. So agenda setting theory tells us that the elite places essentially are setting the research agendas for everybody. Now, that's not a value-laden statement, right? We can ask, and we will later, whether or not that's a good thing or a bad thing. It may have some good elements to it. It may have some bad elements to it, but it's a statement of sort of a mechanism to say that an unequal production of faculty will then drive an unequal distribution of interest in different ideas. So our goal in this section of the talk is to use network ideas to try to test this idea. Okay, so test number one, does faculty hiring drive the spread of ideas? That's just a very basic question. Like, does this third mechanism hold weight? Like, do we find empirical evidence that this happens? So to do this, we're going to use data on hiring events and publication topics. So we're going to take the same data we had from the first half of the talk, and we're going to add to those individuals their publication histories, along with the years in which they were published and the topics that they were on. So we're going to use some basic topic modeling, like actually not topic modeling, keywords, in order to identify whether or not publication was about a sort of a broad category of ideas. And then we're going to test whether or not an idea is being worked on can be explained by faculty placement, okay, and hence the prestige hierarchy. So there are two possibilities for seeing that an idea is being worked on at a particular department, okay? And remember, people are the ones who work on ideas. Ideas don't exist independent of people. So we can get at the ideas by looking at the people. So the first possibility is that an idea X was adopted by the department, right? That department began working on idea X because they hired a person who works on idea X. And so here, what we're going to look at is all the people at that department and their publication histories. And we're going to make sure that there are no publications on topic X prior to hiring a person who works on topic X. And then we're going to check to make sure that after a person who works on topic X is hired, that department now is producing papers on topic X. So this can be attributed to the idea that, oh, we hired somebody who works on X, and that's why our department now contributes to work on X. Okay, so that's check. That's an example of faculty hiring driving the spread of an idea from one location to another location. A second possibility is that the idea was not adopted by hiring. And so in this case, the department might still hire somebody who works on topic X, but there will be people who work on X already there, okay? And if that's the case, then this hiring event did not spread the idea because the idea was already located at that university. So our goal is basically to look at all faculty hiring events and classify them as either being type A or type B. And then we're going to ask, like, do we see more type A's than we'd expect under some kind of null model? Okay. So for three topics in computer science, topic modeling itself, incremental computing and deep learning, here are sort of time series of networks of the spread of this idea. So topic modeling up to 2000 was not worked on very many places. Here we have 2 instances of type A, the idea spread by hiring, and 3 instances of type B, in which the idea did not spread by hiring. For instance, somebody just picked up the tools and started working on it spontaneously. And then we move forward, we see 5 hiring events that look like spreading, and 2 that look like de novo. And then now we have a lot more de novo people just sort of working on the topic in general toward the end of the time period. And this makes sense because topic modeling is a very useful idea. And once it has sort of become known, people could just pick up the idea and work on it on their own. They didn't need to be trained in this idea to begin with. In incremental computing, we see that there is still this sort of, we see some spreading events, but we see many more of these de novo things. And when we look at deep learning, it's even stronger in that sense, right? Lots of de novo learning, people just picking up deep learning and working on it in general. But that doesn't say that faculty hiring is not an important mechanism, right? We want to know whether or not those purple dots are more frequent than we would expect under some null model of people working on sort of random topics or other kinds of things. And so what we're going to do is we're going to compute, first of all, the fraction real hires for, in this case, 5 topics that we have hand coded. And we find that like actually a surprising fraction of hires, like 30 to 40% of hires look like they are spreading ideas to different universities, where universities are hiring somebody who works on an idea that is not currently worked on there. It's kind of nice, actually. And then we're going to compare that fraction under a permutation test, essentially. And this allows us to say whether or not that faculty hiring is a significant factor, not maybe a substantial factor, although it looks like it, but like, or even the main factor, or even all the factors. We just want to know, is it an idea? Is it a mechanism here that has an effect? And the answer is yes, except for deep learning. Like deep learning seems to be a case where the tools were so interesting, maybe, so useful, or the code was available that you didn't need to be trained in deep learning in order to start working on it. Whereas for the other ideas, training was a major component in the spread of the idea itself. So faculty hiring is a significant driver, but not the only driver of the spread of ideas from across academia. Okay, so this is great. This tells us that faculty hiring really does represent a way that ideas spread. So now we're going to do a second test. We're going to take this simple empirical fact and ask, what's the logical extreme of the implications of this idea? Suppose all ideas only spread through faculty hiring. Like, what happens then? So we're going to ask this question of, how does the point of origin of an idea shape that spread, right? So we're going to assume that faculty hiring is the only way that the ideas spread through the system. So it's the extreme example. And then we're going to ask how prestige drives that spread, whether or not the point of origin has any impact in it. Now, I've sort of set up this argument so you know what the answer is, which is that prestige is important. And here's the explanation for it, which is prestige drives faculty hiring, which creates this core periphery type structure, and core periphery type structure drives the spread, right? Ideas originate in the core and they spread to the periphery. Okay. So we're going to model this using a very simple information spreading model, a simple susceptible infected model on a network. This idea is probably very familiar to you due to the past year, but basically we're going to seed a simulation. We're going to take this network as a substrate. We're going to seed an idea at a particular university as a function of prestige, for instance, and then we're going to modify the transmissibility of the idea, which is our measure of how good the idea is. So an idea that is really, really, really powerful, really good, should spread very easily. And so that's going to be a high transmissibility across this faculty hiring network. And then we're just going to measure how far things spread by looking at how many universities end up working on an idea, how far that idea spreads at the end of a simulation. And we're going to normalize that based on the size of the network. So like what fraction of the field ends up working on an idea as a function of where that idea was born and how good that idea was. Okay, now we expect that good ideas should spread really far no matter what, right? That's sort of the baseline. So really the question is, what happens to the less good ideas? Like, does prestige interface with how far they spread? Okay, so we're going to measure this as this plot. So on the x-axis, you have university prestige, where smaller numbers are better because they're higher ranks in some sense. And so Stanford, which is our top department in computer science, and their ranking is like the leftmost point. And then Montana State, which is a low-ranked place, is sort of on the right-hand side. Okay, so if the point of origin of an idea doesn't impact how far it spreads, if how far it spreads is only dependent on the quality of the idea, then we'd expect to see this band-like structure. This would be a meritocracy, right? That ideas spread proportional to their quality. So spread is independent of the birthplace. So a very good idea would spread across the entire system, and a very bad idea would not spread across the entire system. An idea that only transmits, 1/10 of the time, for instance. Okay, and so we're going to run our simulations and just ask, like, what do we see? And the answer is this. It's not a meritocracy at all, right? But this is a structural explanation for the lack of meritocracy. Every individual in this system might be thinking that they're following meritocratic principles, and yet the structure of the faculty hiring market drives the spread of ideas in a non-meritocratic way, such that the point of origin does shape how far an idea spreads. Now, there are a couple of good things. Well, one good thing, which is the best ideas spread really far independent of their origin, right? So these are the red dots. You can see that a red dot that's born, at a low prestige place, it's so transmissible, it just spreads like wildfire no matter what. Okay, so even the top places adopt an idea that's that good. But when you start looking at the ideas that are less transmissible, so you crank down the transmissibility from 0.9 down to 0.7, 0.5, all the way down to purple 0.1, what you find is that Well, the lower quality ideas spread far more easily if they are born at elite universities, the high prestige places. And that's purely a function of their structural position in the faculty hiring network. If you're located in the core, you have a huge alumni network across which these ideas can spread. You're training faculty every year who get faculty jobs at other places, and those people will take those ideas with them to those places. And so the real consequence here, I think, is that good ideas from mid-prestige places, they spread less well than bad ideas from high prestige places. And that's rather uncomfortable a conclusion, that the structure of our system actually drives differences that suppress good ideas in favor of bad ideas based on where they're born. So in thinking about maybe mitigations or interventions that we might want to use to compensate for this. Now, remember, this is a simulation study. So like the real world doesn't work exactly like this, but there are elements to it that do, because we've shown that faculty hiring is a factor in how ideas spread. If you're thinking about interventions, you might think about how you could boost the attention that is given to good ideas from non-elite places, or maybe suppress the amplification that high prestige places get just because they are high prestige places, okay? But we can go a little bit further. We can actually quantify the effect of prestige on the spread by doing this very clever thing called a data collapse, in which we say, okay, well, if we look at the epidemic size as a function of transmissibility, what we find is this like classic logistic function shape, but they have different parameters for this. So, you have a bigger transmissibility, so you get a bigger spread. Great, okay, but how much? What's the trade-off? What's the exchange rate between these things? So if we do this rescaling in which we replace the P with this other quantity for prestige deciles, we can get this thing called a data collapse, in which we take these curves and we renormalize them to show that they all collapse on a single, maybe universal logistic function. And the shape of that function is a function of both transmissibility and the prestige decile of where things start. And so this gives us a way of quantifying exactly what that benefit is of prestige. And we find that it's exponential. So as you move up in the prestige hierarchy, the benefit that you derive for your ideas spreading is exponential in size. So prestige really acts as an attention amplifier in the scientific ecosystem, such that ideas born in certain places receive an exponential amount greater attention than ideas born in other places. Now, again, this is a valueless statement, right? I'm not saying that this is, in this case, bad or good, but it is a fact that our collective attention is driven by these kinds of structural factors. And we can ask the interesting question of like, does that help or hurt science? Or rather, in what ways does it help or hinder science? Okay, so what we've done here is we've used network tools in order to sort of test and show the consequences of this third structural notion of non-meritocratic factors, the idea that scientists carry ideas from where they trained to where they work, and that differences in placement power actually drive differences in epistemic inequalities, right? That some ideas are more popular or known more widely because of these differences in placement power that associate with where the ideas originate from. So prestige drives placement, placement drives the spread of ideas. Our simulation suggests that there's really an exponential dependence on the attention and increasing prestige. So you've got to work pretty hard, for instance, if you want to mitigate that, because the difference is exponential. And the faculty hiring network, really, it's a structural mechanism, right? It's not an individual mechanism, but it creates and then maintains these epistemic inequalities. So your location in the network shapes how far your ideas spread, independent of how good your ideas are. Okay, so let's wrap up. All right, so networks, prestige, and the spread of scientific ideas. Well, I hope I've convinced you that prestige really pervades and structures the scientific ecosystem. We've only looked at a few elements of this system. We've looked at jobs and the spread of ideas, but we didn't really look at publications or resources or things like that. We can look at those things too. They're very fascinating, but I'll leave that for maybe later. Hiring networks, really, they're so cool. They're so interesting. Who hires whose graduates as faculty? And in that part of the talk, we found that there's this core periphery structure. There's the dense core that produces a lot of the faculty, and then there's this more sparse periphery that sort of absorbs it, the homeland and colonies kind of metaphor. We saw that there's this highly skewed faculty production where the core produces a huge fraction of all faculty, and that this, as we saw in the second part, actually drives the spread of ideas. But we also saw that you can embed this network in a one-dimensional latent space, right? This hierarchy is a network embedding in some sense, okay? And then in the second half, we looked at this idea of idea spreading. So the hiring network drives the spread of ideas. We found that prestige looks like an idea amplifier. And it really represents sort of non-meritocratic bias in the system that shapes where our attention goes, right? In a way that's independent of individual factors. Okay, so really hiring networks help us understand this notion of prestige, which structures the rest of the ecosystem. But I want to come back to this larger point that science is really a model complex system. And you can get at many of the ideas that we're interested in for complex systems by studying science itself. Competition, cooperation, feedback, incentives, networks, multiple scales, all of these things exist inside the scientific ecosystem. And trying to understand how they create scientific discoveries, that's actually pretty important, right? Like if we could understand the epistemic processes that lead to discoveries and how social structures and forces shape those epistemic processes, then we maybe could intervene if we're smart and we understand causality in a good way to make things better, right? And I want to leave you with a hypothesis that in fact, scientific discovery is an emergent property of this complex system. That yes, discoveries are made by individuals, but every individual works in a context. And so what I'm working on is shaped by the rest of the system structure. And the discoveries that are made, I think about the fact that like sometimes multiple independent teams are working on the same idea at the same time, right? That's a very interesting coincidence. And it suggests that there's something about the system itself that brings us as a community to the point of being ready to work on a given idea. And then it's sort of like, whoever's close by is the one who actually makes the discovery. So maybe who makes the discovery is less important than the state of the whole system. And that really sounds like emergence. So my hypothesis, scientific discovery is an emergent property of the scientific ecosystem. And this brings us to a few other big questions, which I want to leave you with. Questions like, does prestige help or hinder scientific progress? It's sort of easy to pick on prestige, right? Because if you're not elite, like, I'm not part of that club. If you are elite, well, yeah, I deserve to be here. But like, let's step back a moment and think, does the role that prestige and reputation play in science, does it help or hinder scientific progress? I think you can make an argument in both directions, which makes it interesting. Like, let's try to untangle that, figure out the mechanisms. How does prestige help? How does prestige hinder scientific progress? How much competition is too little or too much? We know that science is very competitive. It's competitive to get jobs, it's competitive to get grants, competitive to get published in certain places, et cetera, et cetera. And maybe the competition has gotten more intense over the past 60 years, for sure. 20 years, probably. 10 years, probably. Last year, probably. How much is too much, right? At what point does competition start reducing the rate at which we make scientific discoveries? I don't know the answer to that question. What changes could we make to the system that would accelerate the process of scientific discovery? I also don't know the answer to that question. And then finally, returning to that motivating question, what discoveries are not being made because of system bias? Also don't know the answer to that question. These are big questions. If we could answer these, then we could accelerate science. We could make it more diverse, equitable, inclusive, et cetera, et cetera. We could do all those wonderful things. But we have to understand the causality inside the scientific ecosystem. And to do that is hard because it's a complex system. Okay, so I'll leave you with that. Here's a list of papers. The top two papers are the ones that I talked about in this presentation. The first one was published in 2015 with Dan Larimore and Sam Arbesman. The second one was with my PhD student who just graduated, yay, Dr. Allison Morgan, Dimitris Economou, who's doing a PhD at Queen's U, and then another former student of mine, Sam Way. And then I want to leave you with a few other papers that I think are very interesting. The third one, Productivity Prominence and the Effects of Academic Environments, continues this thread of what impact does prestige have on, say, productivity, how many papers you write, and prominence, how much attention you get. And then finally, the last one is this editorial that Dan and Roberta and I wrote in Science Magazine about predictions in the science of science, which closes with, I think, a rather important idea of what role does machine learning have in shaping the future of science in terms of, say, like making predictions about who will make discoveries and so on. And I think that there's a very interesting thread of discussion we could look at there. I want to thank the Kaufman Foundation which funded the work that actually collected the original faculty hiring data. And of course, the National Science Foundation has been very generous to us as well. And here are a list of other papers. And I guess I'll stop there and take questions. Thank you.
Yeah, thank you very much, Aaron. Thank you very much. Actually, very provocative talk, in the nice way. So thank you very much. And we'll have a break now, but before the break, I would like to mention something, just to to go to the break and then come back to the discussion. One thing that is basically related to the connection with the other dimension of society, that because we have another participant that came outside from academia, so I'm thinking how your work also relate to those, probably to those dynamics too. I'm thinking, for example, in arts. I'm thinking in companies, how they hire people, where they came from and what happened there. And also I'm thinking in the scaling, because some companies have different, I will say, different part of the company have different stress, I will say. So you have, depending of what you are doing in that company, you will have some different type of dynamic inside of that company and create knowledge or ideas or something. And I think that is important too, because it is something like, for me, is like to zoom out in a different scale of the same problem, kind of, so I will leave that, like, what's happening in the different dimension of society with this type of analysis, also the relation with the scaling, and to mention if you have some idea of what's happening in different countries, like, for example, if you have I will say because you have different type of how you organize your research agenda in different countries, like National Foundation in United States, CONACYT, I think that is the name, in Mexico, or for example in Germany, with places like the Max Planck Society, which make a different ecosystem with the researcher and the researcher institution. So what do you think if we go, Carrie, if we go for a break of how much, 10 minutes, 15 minutes, to have a cup of coffee? Or
Yeah, Isa will manage this.
yeah, Isa, please let us know when we come back, actually.
Sure. So what I'll do is I'll open breakout rooms so you all can take a break, get some water, coffee, whatever you need, and feel free to start discussing in your small groups. It'll be about 10 minutes, and then I'll bring you back and we can do the large Q&A with Aaron. So I'm going to open those rooms now.
Thank you. Hello, everyone. So let's see.
Not quite all back yet.
Oh, okay, I see.
One in 42 seconds.
Yeah. Aaron, if you have any answer to the question that you already saw in the chat, please, we can begin with that, and then we'll follow the raise hand line that appeared here in the chat. So
okay.
Yeah.
Okay. Well, there are a lot of questions. Thank you, everyone, for writing questions. Let me just sort of skim through them and answer a few. Okay, so there was a couple of questions about basically why do we focus on faculty in our analyses?
Yeah.
And it's an excellent question. We are interested in these general ideas everywhere. For instance, we believe that these kinds of processes also hold in industry and in organizations and in government as well. And it's harder to study those ideas in those environments because it's just really hard to get the data, right? So if you wanted to understand the way prestige and rank and position and individual characteristics intersect with the spread of ideas and the attention that you get in an organization, you need two things. You first need to be able to quantify ideas and attention. And in an organization, that's already hard to do. Academia is kind of nice because like we publish papers, that's like the main currency of the realm. And so you have this imminently quantifiable thing that you can use in order to get at that underlying question of attention and prestige and so on. Excuse me. So that's one part, is you need a way to measure the output. And the second part is you need to be able to get the people. You need to be able to measure who is saying what and what attention are they getting. And inside an organization, all that data is private and not available outside the organization. In government, it's also kind of tricky because so much is not sort of recorded, but academia is a model system in part because all that stuff is publicly available, right? You can find the faculty on a departmental website because they're listed there. And faculty have this wonderful habit of putting their CVs online, and their CV has all this interesting information in it. And there's also this infrastructure now, the citation counts and Google Scholar and so on. So it makes these ideas easier to study. And that's why I say it's a model system by which we can learn about these processes, these ideas, and then try to think very hard about how we could test them and apply them in other non-model type systems. Even inside academia, we are also interested in looking at other kinds of people, postdocs, graduate students, undergraduates, research faculty, et cetera, et cetera. But they are much harder to find. In many ways, the system makes them invisible because the institution isn't like putting out a list of all the graduate students in every department. Some departments do. So my graduate department at UNM down the road from SFI did have a list of all the graduate students, the PhD students at the current time. But my current department, CU Boulder, does not have a list of all the graduate students. Postdocs, maybe you could get that information from people's websites, the PI's website, or their own personal websites, but it's much harder to find that information. And so in some sense, those individuals are more invisible. And so by focusing on the faculty, we can at least be sure we can get a pretty good, complete census of that part of the system. And that gives us then a toehold into understanding other parts of, say, the academic progression in terms of a career, and also sort of ideas that we might then be able to apply in companies or organizations. Economists have been very clever in trying to explore some of these ideas in the context of organizations, but they have to be really clever in how they do it. One thing that is very promising for that direction is GitHub. So now GitHub is a way that we can sort of record contributions in software. So much of business now is software, and many people even use GitHub as a way of recording progress for version control and other aspects of their job. And so maybe that will be a new mechanism by which we can get insight into the productivity and so on of individuals outside of this simple academic context. Okay, so that was a couple questions.
Yes, and please, the participant raise your hand, and we can follow that also for the question. So we can have some, for example, so we can have a one-to-one conversation. I think that is a beautiful way to have this dynamic too. So some, please.
Thanks. Yeah, Afsa, thanks for your presentation. It was very interesting. Couple of questions. One, I was curious if you have thought about looking at this from a gender lens, or looking at minoritized faculty, like how that comes into play, and in terms of idea spread, in terms of influence, et cetera. The other is, have you had a chance to look at those who might leave academia because of this existing pervading structure that exists, that may not promote alternative ideas, or ideas that are not promoted by higher up. So just curious about.
Yep, absolutely. We are very interested in those questions as well. So we put a preprint online. Excuse me, I'm getting over the cold, I guess. We put a preprint online a few months ago called the Socioeconomic Roots of Academic Faculty. And that was specifically trying to look at this question of SES status, but also race and gender in terms of who becomes members of the professoriate. And that was our first sort of foray into looking at that element of it. So who becomes members of the faculty group. We've also looked at some elements of gender. So we looked at gender in faculty hiring, for instance, and you can find some interesting correlates there. In fact, there's a huge, very interesting literature in this specific space about looking at the characteristics of individuals like gender and racial or ethnic status or characteristics, and the relative contributions and attention that people receive in science. We also are just beginning to launch a study looking at people who leave academia. So you may be familiar with this idea of a leaky pipeline, which is this idea that at each stage of the academic career, from undergraduate to graduate to postdoc to assistant professor, associate, full professor, and so on, that women leave academia at slightly higher rates than men. And there's been a lot of work done on that topic as well. We recently acquired a very systematic data set, essentially on all tenure track faculty at all PhD granting universities in the US. So it's a huge data set, 300,000 plus faculty. And we've been trying to dig into quantifying that idea for different departments in different fields. And we're going to couple that analysis with a survey in which we actually ask people, both people who stayed in academia and who left academia, like, what are the stresses that you experience in your job? And we're very interested in understanding how those stresses intersect with prestige. So like, are the high prestige places more stressful for different kinds of people than other lower prestige places? And also, do people with different characteristics experience different kinds of stresses? And so hopefully that will allow us to help quantify answers to some of the questions that you suggested.
Could I just build on that for a second? Because you said you're doing
Sure.
this analysis. I wonder if then you might be comparing what's happened with COVID and the impact, particularly on female academics, because of caregiving responsibilities, other responsibilities, there will be a huge impact. And so already there's research showing that female faculty have published less and have fewer grants in this period.
Absolutely, there's a really great, great in the sense of insightful, but very depressing in the sense of the actual consequences. Thread of literature quantifying exactly what you just said, which is that because scientists are individuals and we have responsibilities outside of doing science typically, and those vary with characteristics associated with the individuals, that of course the pandemic has hit different people different ways. We are not currently doing any work specifically on the impact of COVID, but certainly it will intersect with some of the work going forward. Like, in every big social data set in the next 20 years, like 2020 will be a year that requires explanation for posterity because it will look so different. And the effects, we assume, and there's already evidence that says this is true, those effects will echo through, will ripple through into the future in ways that I think some of us have some ideas about how that's going to play out, but I think there are going to be a lot of surprises as well. Okay. Next question.
Yes, Joshua, please.
Okay, thank you.
Yeah, don't worry.
Great. Hi, thank you so much for your talk. It was extremely interesting to me. One of the questions that I have based on that is, when we're talking about the idea of measuring the quality, you focused on transmissibility of the idea. I was wondering if you or your team, based on the data, had looked at different ways of measuring the novelty of the idea. So is this, for example, with topic modeling, is this, truly a new way to do topic modeling, or is this idea just kind of another recasting of LDA as an example? So just kind of separating out what's truly novel from just kind of something that's kind of more or less regurgitated in the idea.
Yeah, it's a really good question. It's really hard to develop a believable measure of quality that you can extract from the kinds of data we have access to, right? Quality is something that you might know it when you see it, but we have a really hard time teaching computers how to see it. And so although my group has thought in various ways about how we might develop a measure of research quality, we've basically not done it because we don't believe any of the things we've come up with. People often use things like citation counts as a measure of quality, but other researchers criticize those, rightly so, as being mostly about attention dynamics. And so therefore highly gameable and maybe not a good measure. We can all think of papers that are highly cited that are bad. And so we have not dipped our toes into that side of things, thinking about quality. And the particular work that we did, we looked only at whether you were working on something or not about whether or not it was a better or worse version of that thing that was being worked on. And so in some sense, we are unable to see how a field is progressing in terms of the character of the work it's doing, only whether or not that work is being done or not.
Thank you.
Kevin Yarritu, please. If you're there, Kevin.
Oh, yes, I'm here. Yeah, so I was just wondering, maybe the data isn't there, but in what sense are your ideas about prestige and idea transition applicable to other paradigms of institutions, not only academic, but how ideas spread across the United States, where they come from, stuff like this. But I think the data might be a little more harder to get in that sense. But I was wondering, that's my question.
Yeah, I mean, I think it would be wonderful to be able to translate some of our findings or questions into other domains, especially like larger societal discussions in terms of how ideas spread. And fortunately, there are people who are doing that. There's a huge amount of work being done on how things happen in social media, or rather the role that social media plays in advancing certain ideas. But it's also very difficult because so much of what happens in the broader sort of societal discussions is not available, is not seen in a public way. Not clandestine, that's sort of an intelligence term, but so much that influences the shape of our conversations happens behind closed doors and is housed inside private organizations. And that makes it very difficult as a researcher to try to study those particular ideas. So you have to be pretty clever, try to find the right question, the right idea, the right kind of data in order to do those kinds of evaluations. To give you an example, Duncan Watts at the University of Pennsylvania has gotten himself access to the Nielsen TV viewership and web browsing data. So Nielsen tries to build a representative sample of individuals in the US to measure their media consumption in various ways. And of course, they sell that information to other media companies to know what kinds of movies to make, what kinds of TV shows to make, and so on. Duncan Watts was very interested in understanding the role of fake news in driving certain kinds of political discussions. And his findings are very provocative because basically what he says is that social media is a drop in the bucket. It's mostly mainstream media that does it. Disinformation is a mainstream media phenomenon. And even though we are obsessed with Twitter and Facebook and stuff, there are many, many more hours our society spends watching TV than browsing Twitter and so on. And so that's an interesting finding. It suggests that we may be paying attention to the wrong thing because the data is available for Twitter, but it's not available for TV viewership.
You're right. Yeah.
Aaron, thank you, Kevin. Aaron, just a little mention that yesterday we have an introductory talk by David Krakauer, and he touched also the idea of how, as a society, we have built the institution of research, of knowledge, and how probably those will change in the future. And I imagine that these results that, probably are very, very robust in terms of nation and etc., is a global kind of pattern. It's related with the stability of those institutions, the stability of how those institutions probably have self-generate in the past, but now they have, they are very stable. I mean, you have fixed point that is very difficult to move around, to have this prestige move around. And I mentioned this because, trying to connect actually the yesterday talk where, David was discussing about that, how probably this institution will change in the future in order to have more interdisciplinary research and, a big picture of the problem, the global problem, etc. And connecting this with this really how these institutions are very stable in terms of the ranking, in terms of the hierarchy that also create the flow to this knowledge and the prestige. Just to have this in mind.
Yeah, I think in fact that raises an interesting complex systems question, which is how do you design a system to produce a stable institution that is robust to perturbations of certain kinds, but maybe still adaptable to certain kinds of changing circumstances? And one thing that has sort of come out of looking at these prestige rankings in academia is that they are incredibly robust. And this work is not mine. This goes back 100 years. The Ivy League has been the elite institutions in the U.S. Forever. And even as the notions of meritocracy have changed, sometimes they have been the ones to change them. even as the rules of the game have changed, or the opportunities and the resources available have changed. Like after World War II, the federal government got into research funding in a big way. And you better believe it that the Ivy League was really set on getting that money, and they were successful. And now they are continue to be successful. And so the ability for this sort of collective system, the scientific ecosystem, to maintain its basic prestige hierarchy in the face of all these perturbations suggests that there are some, balancing forces that were set up that are very basic that preserve it. This is maybe an economics type question, which is how do you design institutions and so on. But I think it's very interesting.
I can imagine that one strong mechanism to this kind of robustness is that you review the institution from the institution, usually in academic, and that is a very peculiar way of, of reviewing yourself. I mean, and then you create it. So that's what's happening with it. Yeah.
Or rather, you review your peers.
Of course, yeah.
But you were trained at your peer institution, and is that a conflict of interest?
Of having, for example, the same ecosystem of people in the same magazine, in the same journal, etc. You reviewing yourself, which is kind of, and that I think.
Or a small community reviewing itself, each other. But this raises the question of you want experts to be the ones reviewing, and science is a thing where expertise is so esoteric sometimes. And so if you try to cut those clear conflict of interest ties, you may also be cutting the expertise. And that balance of how do you manage the conflict of interest in terms of me getting resources for myself or my larger extended family intellectually versus having expertise that can actually evaluate those ideas, that's a hard problem to balance, I think.
That's
one that requires us as academics to accede to this principle of trying to be objective and trying not to be biased and trying to be upfront about our biases. And that is a constant struggle. That part never ends. Okay.
We have at least 5 questions, so let's go for those. Boris, Natalia, Sasha, please, Boris, if you can jump into the discussion.
Sure. Hi. I wonder if you have looked into any areas where this prestige effect is not that prevalent, right? For example, I was thinking at blockchain and crypto, where there is not a clear set of prestigious institutions that dominate. Actually, a lot of the knowledge is coming from non-traditional places, even organically from hackers, and so most of the data are coming from the community, not like from institutions. So have you found any areas where this prestige is not as influential as most of the academia, like computer science or something?
Yeah, well, most of my work in this area has been focused on academia, and as I started with in the talk, little in academia makes sense except in the light of prestige, and so I would tentatively argue that the null hypothesis for academia is that everything is connected to prestige in some way. Now, there has been one sort of provocative study to me, maybe not to other people, which suggests that the field of ecology is much less organized around prestige than other fields like molecular biology. And this is interesting. It raises the question of, well, how do they do it? And is this a transient? Will the high prestige places eventually run the show? And maybe this is where it connects with things like blockchain, which is right now, this is a new phenomenon. And maybe that provides the opening for a more diverse set of voices from different communities to participate. But if blockchains become something that the elite, prestigious, powerful organizations decide they should care about, how long will it take before all the voices are now located at those places? Either because those places train new voices that then dominate, use that influence and authority and prestige to insert themselves in that conversation, or they just hire the people who have the loudest voices and say hey, let's make a blockchain institute at Harvard and you can all be affiliated with Harvard. And people are like, yeah, that sounds pretty good. I'll move over there. You can see this kind of effect happening inside academia, for instance, in systems biology. Harvard literally just created a systems biology department and hired top people from around the world to become faculty in this brand new department. And hey, presto, they have the #1 department in systems biology now, right? So this is a way that established institutions can sort of buy their way into a new game by using the prestige and authority and resources that they have accumulated from other kinds of games. And I think it's a legitimate question as to whether or not that is a good or bad dynamic. And I want to suggest that it might be more complicated than a simple yes or no.
Thank you.
Great.
Hi,
Natalia?
Aaron. Yeah, that was really fun. Thank you for your talk. If I may, I want to ask at least two questions. One is of a more just like procedures. I wanted to know, when you model transmission, are you also using the multigraphs that you built initially, or are you assuming that there are fewer edges between the nodes?
So we're just using the faculty hiring network as the substrate. And so that network is just edges that represent hiring events.
Okay, so if you had more than one hire connecting two universities, you only have one edge.
No, it's weighted, and so every hire is an edge. So it is a multi-graph in that sense.
Yeah. And the other one is along the lines of what other people have discussed in the chat. I was worried that the financing institutions will like generally exert the sort of force that opposes like going against these inequalities that you point out in your work. Yeah, so is there anything that you would suggest, or because I mean, one of the questions that I was making about how these networks may have changed over time is very much related to the fact that financing institutions have gained power, and they are what defines science a lot these days.
Yeah, you mean the like funding organizations like the National Science Foundation in the US and so on. That's true. I would gently argue that while funding organizations may have come to recognize their influence to some degree, they don't understand how to use that influence very well. So for instance, if you look at the doubling of the National Institutes for Health budget in the US that happened in the early 2000s, that money basically got soaked up by the system and not much else changed, right? Like universities built some new buildings and they hired some new faculty, but the character of the science didn't change to the extent that you might imagine when you double the budget. And so it suggests that the universities have a lot of influence over like what actually happens. And so trying to understand like how do you push the system in a certain direction requires like really characterizing the causality of this complex system. And that's complicated because there are so many different actors interacting in different ways along with incentives and so on. And if could the NIH have allocated that money in a more surgical way? Well, maybe, but the NIH uses peer review in which they have academics at those institutions reviewing the grant proposals, which is the right thing to do. It's the expertise way to do it. And so like, the system just ate the money. We got a lot more science out of it for sure, but like, did we cure cancer yet? Like, we're still working on that. Like, we're making small progress towards that. And that's interesting. Like, the system is so much more complicated than the most of the narratives that we read about really say. So I think, yes, the funding institutions do have influence for sure, and maybe they're getting better at wielding it, but they're still not very good.
Sorry, and just the last point, I think that the model that you're proposing also is omitting the fact that some new hires may produce local transmission events that lead to more papers in that field, in that institution, right?
Absolutely. I mean, we're throwing out all the interesting things about the spread of ideas just so that we can measure one thing. So for instance, we're not trying to quantify like conference presentations, right? So like I might go to a conference and see a presentation, I attend a summer school and see a presentation and be like, that's really cool, I want to work on that. And that's a transmission of an idea that we are not modeling in any way whatsoever, right? Yeah. So we really laser focused on just the faculty hiring transmission mechanism, but being able to quantify the role that conferences and like what effect has Zoom had on the spread of ideas? Like it's had an effect, but how do we measure it? And how do we quantify it? And like, you know, there's much more work to be done here for sure.
Yeah. Thank you, Natalia. Sasha?
Thank you. That was a very nice introduction to what I wanted to ask. Do you think it's reasonable to say that the origin of ideas claim that you make with that analysis is valid without considering the funding agencies? Because nobody just comes and is hired with the knowledge of a topic that hasn't been funded by your supervisor in the previous university, and who then gives you the money that you can actually develop this idea. So you're tracing this and you show the sort of the growth of it, but I was wondering whether the boundary was reasonable without actually, because the money is driving this, not the hiring. But so I wanted your comment on that. What I'm more interested in, though, your opinion on the citation practices and to what extent you think these individual practices may disrupt the visibility that's imposed by the informal networks across the universities, and whether things like quotas are reasonable, because, you know, I mean, improving citation practice is a beautiful idea, but everybody I talk to would say, well, but we don't want to do quotas, right? We want to quote people based on their ideas. And so what's your view on the citation practices as a level down from this? So level up and level down.
Let me answer your second question first, and then you can remind me of your first question after the end. So most of my work is focused on the people, but there's a huge community that focuses on understanding the citation practices and building metrics in general. And so Cassidy Sugimoto, for instance, she's now at Georgia Tech, and Vincent Lavière he's at University of Montreal, I think. These are my two favorite scholars in this space. There's been an enormous amount of work trying to understand how, like, what does a citation mean? And it's clear that it correlates with impact and importance and attention in the scientific community, value in the scientific community. But it's only a correlate. And there's substantial evidence, many different directions of evidence, suggesting that these numbers are manipulable. They measure, you know, attention, transient dynamics in terms of, like, you know, hot fields versus cold fields and so on. And that they are driven by things that are not meritocratic. So for instance, in our work, we have been looking at how prestige intersects with citation counts. And what we find is that, of course, you know, the scholars who work at the more elite institutions receive far more citations than those who don't. And the difference in magnitude is true even for small differences in prestige, which suggests that, like, there's something weird going on there. It's not just about the quality of the idea. Like, does Princeton produce ideas that are really 1.25 times more important than Yale, even though Princeton has, you know, 25% more citations than Yale scholars do? Like, probably not. And so this really suggests that there are other mechanisms that are driving the citation counts. And so, to get to your point, the idea of having, like, personnel decisions being made based on hard, arbitrary numbers associated with citation counts or publication counts, it doesn't feel like it respects the thing we care about the most, which is the value of a scientific idea, which, in my mind, as I said earlier, like, I don't know how to teach a machine how to measure the value of ideas. And so, do I trust a metric to be able to quantify that as well? Probably not, because that's something a machine could learn. And so, in this tension between, clearly there's a correlation between these metrics and scientific utility, and the fact that it's only a correlation, and in so many cases can lead you to make wrong decisions, highly cited papers that are wrong, for instance, or bad science. I mean, we can all point to papers in Nature and Science that are crap, and yet they appeared in these very fancy journals and received huge citations. Suggests that we should be very, very, very cautious about relying on metrics. So the essay that I mentioned that I wrote for Science Magazine about data-driven predictions in the science of science, it closes with a meditation about this idea of how predictable are these things? And if there are things that are unpredictable about scientific discoveries, then quotas will not be sufficient in order to capture them. And therefore, we should be extremely cautious about trying to automate, which includes committees, you know, having rubrics like you must meet the minimum number of things or whatever. We should be very cautious about automating these things because they are likely to double down on old ideas. Whereas the value of science comes from the newness. Like, how do you predict a new discovery when all you have is information about old discoveries, right? New discoveries are different. And yet machine learning and quotas and things only learn from the past. So it feels to me that we need to think more carefully about how to use metrics in the evaluation of both scientists and science and organizations, and that the current practices may be effectively a kind of non-diversifying selection, narrowing the scope of ideas to focus on things that correlate with prestige, because those are the people who do well on these metrics.
Okay, thank you. My first question was about the money. What about follow the money? But what I was really trying to say with the citation one was, if individual agents make deliberate decision, because we all know that citation numbers are overblown, especially after a particular threshold. If individual agents make deliberate decisions not to cite this one paper that first comes to their mind, do you think that that low-level collective activity can disturb the visibility that otherwise is imposed by the system? That's really what I was asking.
Okay. Thank you for clarifying. I definitely didn't get that out of the first version. That's very interesting. And I think, so how we cite things is definitely a cultural norm. And this is something that we learn in our research training, is how do we choose which papers to cite? And if we as a community create a new norm, shifted from the current one of just cite the most prestigious stuff or cite the paper in Nature that talks about it, and instead we make deliberate choices, as you were saying, to cite differently, then I think it could change things. It will be difficult because there's a lot of incentive and pressure that's driven by prestige and money and things like that. But maybe the impetus that we should really take away from it is we should be more deliberate in the way we cite things, and deliberative. And I do think that that will change things in the long run. It's just, it'll take a long time because the system is big and complicated. To get to your first question about the money, yes, money is incredibly important. How important it is an open question. And I think that that's what we should consider, is because the funders are not the only player in the ecosystem, the universities are also, there's a tension between the priorities and the agendas of these two organizations that are all influencing what individual researchers do. And that's a research question, is to figure out like, what's the relative importance and the dimensions and so on.
Thank you.
Elisabetta?
Yes. Thank you for your presentation. I found it very interesting, especially in the part that underlines how the spreading of ideas is correlated to the prestige of academia. And since I also am curious about how information spreads, for example, in online social platform, etc. I was curious to understand if the measure that you have used for ranking the prestige of university is a centrality measure that was already known, or if can be I don't know, used in other type of fields, etc.
So any centrality measure is basically a ranking of the nodes, right? We want to order them based on some number, and we compute the function. The function that we compute for that number is a function of the network structure and so on. And so, yes, the prestige ranking is a kind of centrality measure in that sense. Just as eigenvector centrality is, harmonic centrality, there's an endless list of these centrality measures. And so the prestige measure that we used is not novel to us. We pulled that off the shelf. It came from the literature on minimum violation rankings, which, as I mentioned, is sort of well explored in animal social systems. For instance, looking at primate troops and the social hierarchies there, minimum violation rankings are very much associated with particular social dynamics there, because if I, as a low-ranked macaque, do something like pick a fight with a high-ranked macaque, if the hierarchy is very strong, that should be a very rare event, and there should be consequences if I violate that social structure. And so that's where that literature came from, and we just sort of borrowed from that idea. But you could use any measure of network structure as a notion of prestige. And I think the question then is, which one is more useful? In our case, in the 2015 paper we wrote, where we introduced this idea of prestige rankings and so on, with the minimum violation ranking, we did a simple prediction task. We asked which of these various centrality measures is more predictive of placement. And what we found is that, well, they're all correlated because they're all coming from the same network. But some are more predictive than others. And the minimum violation ranking measure of prestige is ever so slightly more predictive than anything else for placement. And so that helped us sort of make the case that this was a useful way of characterizing the importance of these nodes in the system for hiring. But of course, for other kinds of networks, you might want a different measure of centrality, something that was more grounded in whatever the social dynamics or social theory is, or economic or biological theory that underlies the dynamics of that system.
Okay, thank you.
Greg?
Hey, great, interesting talk. I'm one of the few policymakers or few folks from industry, and I'm always asking the so
Great.
what. Can you hear me okay?
Yes. Yes.
Okay.
Perfectly.
All right. Great. And so, just I'm curious from maybe a general perspective or from the literature. Is there any literature on how to influence the system? And do you influence the edges? Do you influence the nodes in an ethical way? It struck me one of the things you had said, even when it comes to citing, is that we all should be more deliberate in citing, but yet there's so many system pressures. I don't know if there is a should statement in there, if that makes sense. And I'm just curious on the application side of it. Okay, we've mapped this network. What can we now do about it?
There's definitely a lot of people talking and trying to understand what kinds of interventions you could do, what kinds of policies you could create that might change the way the system works. Right now, many of those are focused on things like diversity, equity, and inclusion. So trying to think about how underrepresented groups of people are treated by the system, and whether or not they're whether or not we're sort of meeting the criteria of these ideals that we have. But there are other ways that you can intervene in the system that have been looked at as well. So for instance, thinking about the citation practices, so journal impact factors were a very large thing for many decades, and the bibliometrics community spent a lot of time studying them and have come up with essentially a list of bad practices that journals do to manipulate journal impact factors. And as a journal editor myself, I read these things and laughed, because I was like, oh yeah, look, my journal does half of those things. And from my perspective, it was more of a list of things that we should try not to do, right? So I think the value of the research is in identifying both being able to describe the system well enough that you understand its current state, but then trying to get at the causality. And that's so hard because it's a complex system, right? We have complex effects, and we have complex causes. And that's where the hard work is. And in some sense, the policy implications and recommendations we have right now are very laser-like focused on specific things, like problems that seem like they're solvable, like being able to change the funding rates, for instance, for certain underrepresented groups. For instance, there has been a lot of work at the NIH in the US looking at how minority scholars get less money from the NIH than white scholars do. There's a very nice paper published a couple years ago, I think, that showed that part of the difference in funding rates is explained by differences in topics, that there's a correlation between what you work on and your racial, ethnic, and gender characteristics, which is not surprising at all, right? We all have interests that are dependent on our identities and our ideas. And so if we work on the things that we ourselves care about, and those correlate with our other characteristics, then you will see differences in these topic choices. And if the institution values those ideas differently, you will see differences in funding rates too. And so this study I really liked, because it highlighted the fact that if you want to solve this larger problem of inequality in terms of funding rates, then it's not just a matter of one group, taking all the winnings or the proceeds or whatever. It's actually tied up with our own preferences. And so coming up with a policy change has to recognize the causality of the difference to begin with. First, you come up with the description, here's the problem. Then you figure out like what's causing the problem. only then can you really design a policy that is going to be targeted to actually have the effect that you want to. Otherwise, you're going to get things like the example I gave earlier about the NIH money doubling overall, and like academia just ate the money and kept doing what it was doing, right? So you can have policies that don't have the effect you want, like that one, and you can have policies that do have the effect you want, like, for instance, NIH has a specific scoring system for first-time PIs, in which if you are not very good at writing grant proposals because you're young, then you're not held to the same standard as the senior people who have lots of experience. Like, that's a great program and it works, right? So they've done plenty of evaluations to show that indeed, like, that helps the young people compete for the same money that the old people have an advantage for. So it's a complicated issue. There's lots of work being done, mostly on the inequality side of things. The question of trying to drive overall discovery is more complicated because we don't really understand what drives scientific progress. As I said, my hypothesis is that discovery is an emergent property of the system. And that means it's going to be a while, I think, before we really understand how to like laser target money in order to make specific kinds of discoveries, outside of the fact that, like, if the experts say, like, yes, we can increase the efficiency of batteries if we just dump money into it, like, that's what happened basically. Like, that's not as interesting as like let's invent a new field and, you know, stuff like that.
Yeah, and I will add, Aaron, if I can, you know, I think Greg raised a very nice question because it relates also to public policy, and I think something that is very good to remind is that there are some metrics that are not, you know, very easy to understand, in the sense that they are kind of second order description of your of the object, or second or third order description of the object you are trying to study. Even though that I think there are a few journals that are working in public policy, quantitative public policy nowadays, and I think that is a very nice place to explore also how to use these metrics. And we can talk about that, you know, during the groups formation, etc. Those particular places, those journals that are in a one-to-one relation between, you know, complexity science and public policy, which is nice to explore. I don't know if there is another question. I think there is. Yes, Kyle.
Hey, thank you for taking my question, and thank you for that talk, Aaron. Can you comment broadly on what types of systems this prestige ranking is endogenous of? And can you comment also on when it might be useful? Like, from my perspective, things like ranking in monkey tribes, maybe that's useful, but maybe like the distribution of wealth is not useful. You made a little footnote in one of your slides about the Gini coefficient of wealth distribution, and you compared that to the Gini coefficient for academic rankings.
So I think, I mean, so much of human social dynamics connect with this idea of social status. This is something sociologists have known for a long time, like, get a whole PhD. There's whole shelves of textbooks on the role of status in social dynamics. And so I think it's difficult to untangle status from human behavior. And in the work looking at animal social behavior, that's exactly what they're studying, is how does status inside these small animal systems structure the social dynamics? And they treat them as model systems because human society is so complicated. And yet they always say, like, yes, this applies to human behavior as well. So if you think about whether or not like prestige rankings or status rankings are important for other kinds of social systems, I think the answer is always yes. But then the secondary question is, well, how much do they matter? And that's harder to answer. It really depends on the particular kinds of dynamics you're studying, the kinds of research questions you're interested in, and so on. But probably it's important to some degree. It may be very subtle, for instance, and it may differ based on the scale of the system you're thinking about. If you're thinking about social dynamics inside a small team at a company, status may not matter as much because there's sort of a collective agreement on what they're all there for. But when you start looking at teams compared across the company, like, status may actually matter more in that context. Certainly in academia, like, there's there's a tension between the competitive nature, which is sort of status oriented, of academia, and the cooperative nature of science. Like increasingly science is done on teams, sometimes very large teams, and you have to mitigate status seeking behavior in order to make the team work. And so that tension is interesting, and trying to understand in what context is there cooperation versus competition, to what degree, and how do they sort of interact with each other. I think that's probably the right direction to go when you're thinking about some general social system, in order to understand like how much prestige and reputation and status really matter, is think about this cooperation and conflict kind of thing.
Great, thank you.
Let's see. Nice. I think we are ending the round of questions. Yes, I think there is no more raised hand. There is one question there for you in the chat. I don't know if you want to take that as
at the very
last
end.
question.
Let's see.
It's a long question.
Yes, I think, okay. If I'm understanding it correctly, it's asking about whether or not you could use inequalities at the institution level versus the individual level to sort of compensate for each other.
Yeah, exactly.
That's an interesting idea. I imagine the answer is yes. And the question is like, how would you do that? Certainly the institution level of the system has many fewer players in it. And the individual level system is like much bigger and much more chaotic. And so if information or attention can go through one level down, go up and then down, or go down and then up, those are two different mechanisms by which you can mitigate the sort of prestige dynamics of the other one. And so, yeah, like exploring that question of how you can use one to compensate for the other, I think is a kind of a cool idea. Yeah.
All right.
Can I close with one comment?
Okay. Yes, of course.
So I've tried to present these findings sometimes with value laden things, but also pointing out that like it's more complicated. I want to maybe close on a point about interdisciplinary research and how messy and not clear some of like the norms might be in terms of their value for science overall, which is, I mean, I'm an interdisciplinary scientist. I love it. I really prefer doing things that way, but there are disciplinary scientists too. And sometimes people like me, I mean, my background's in computer science, and here I am doing sociology, basically. There can be sort of boundary maintenance work in which members of a community say like, no, like stay out. We don't want your stuff here. And that's an experience that many interdisciplinary researchers have, in which they are trying to take ideas from one field to another to contribute to them, and that other feels like, no, we don't want you here, or something like that. And that's not like, the reason that behavior exists is not all bad, right? So in physics, for instance, there's this phenomenon, all the physicists in the audience can laugh about, cranks, people who are like, oh yeah, I figured out how the second law of thermodynamics is wrong, or like Einstein was wrong about general relativity, and like I know how he's wrong. And this is a phenomenon of people making statements about the science that like people inside that field can recognize as being incorrect. And so interdisciplinary science sometimes feels like cranks. Like I'm the crank in sociology. I'm coming in and being like, you should be doing this computationally. And they're like, that's not how we do things. And so the question of boundary maintenance with respect to scientific progress is really about, how do we know that we're making progress on a question? And different communities actually have different norms and ideas about what progress means and what makes a question interesting. And the fact that there is that heterogeneity across communities makes it really hard to define like scientific progress in one giant, unified way. And therefore you get people who are cranks and people who act like cranks and who are cranks. and people who act like cranks but who are not cranks. And being able to tell the difference is sometimes really, really hard. And so thinking about like the role of prestige, for instance, in amplifying ideas from elite places, it may be that this is actually a really good thing for science because it allows the scientific community to synchronize its ideas really quickly, right? That they act as these big speakers. And so if a good idea emerges anywhere in the system, everybody will hear about it because the elite places will start working on it, and then everybody follows them. And if there is a good direction to go, like we will move more quickly in that direction because of this prestige hierarchy, perhaps, than if we had a truly decentralized, completely democratic, everyone's equal kind of system in which things would move more slowly. And so that's why I tried to sort of emphasize that, like, it's complicated and it's not clear what are the benefits and what are the costs. And I think trying to think through those different consequences is really one of the things that makes thinking about science as a complex system so exciting. And I'll stop there.
Thank you very much, Aaron. Thank you. Wonderful talk, actually, because, you know, I think it crosses many dimensions of our society. So thank you very much. And I will give you an announcement that tomorrow, after the question and answer session, we'll give some information related with the formation of the groups and the group dynamics, and we will give some info about that with Santiago. So that will be tomorrow after the question and answer session. And for today, we will have a break of 30 minutes or so, and then we will meet again for all the people that want to. And I think that is, I encourage you to go there to the gather place, just to have, again, following this interaction and this formation group, the self-organization of our group's formation. That is, it's going amazingly well, you know, in Discord. So thank you for that, and I'm very happy for that. So let's meet again in 30 minutes or so. And Aaron, thank you very much. Very nice to see you. So I hope to see you again soon.
Thank you all.
Bye.